Hey guys, I just wanted to really quickly go over the last part of the free response question due today. That was free response question number two. Um, in this question, they gave you at the stem of the question that f prime of x was equal to x minus 3 times e to the x. They told you that f of 1 was equal to 7. And in the last part of the questions, part C, they wanted to know what f of 3 was. Now, what a lot of you did, and you did it correctly and you ended up with the right answer, was you found the antiderivative of this and you got your plus c. And then you solved for c by using that initial condition over there. You got your function for f of x. You plugged in 3 and you got the right answer. It's a legitimate method for a problem like this. But the question was not designed to be answered that way. This is the way they wanted you to answer it. And I think it's important you understand this because the AP loves to look at this question in the following way. So here's what they wanted you to do. They wanted you to consider the integral, the definite integral from 1 to 3 of f prime of x dx, and realize via the fundamental theorem of calculus corollary that this definite integral is going to be the antiderivative of this function evaluated at 3 minus the antiderivative of this function evaluated at 1. In other words, f of 3 minus f of 1. So the AP exam loves to take a look at that fundamental theorem of corollary and then kind of mess around with it and put it into problems like this. And they also like to write it another way. So basically you can take this, add f of 1 to both sides, and you get this. You get f of 3 is equal to f of 1 plus this integral from 1 to 3, this definite integral, from 1 to 3 of f prime of x dx. And of course, when I see this, I actually think of another place where they use it on the AP Calculus exam, and that is in physics applications, right? And we've seen this year. It's like if I have S of B, so if I want to know what the position is at a value time equals B, or t equals B, I could get it if I know where I started at time equals A, which of course is S of A, and then I can add this integral from A to B of velocity. Now this integral over here, the integral from a to b of v of t dt, well, what is that? Is it distance? Is it position? Well, you know what? I think it's neither of those actually. What it is displacement, right? Which makes sense because it's like, where am I at time equals b? Well, I was somewhere else at time equals a. If you add the displacement to that, you'll take me to where I am at time t equals b, right? So this is displacement right here. It would be distance if we were doing the definite integral of the absolute value of velocity though, right? But that's displacement right there. And of course, another way of writing it would be S of b equals S of a plus the integral from a to b of S prime of t dt. And again, that is what I was thinking of as I was writing this, right? Because like I said, the AP likes to mess around with this fundamental theorem of calculus corollary, just like this. All right, so f of 3 is what we want. So f of 3 here is going to be equal to f of 1, which is 7, plus this integral, the integral from 1 to 3 of f prime of x dx. Okay, now, another reason I wanted to take a look at this question is it was a good question because it forced you to review your knowledge of integration by parts. I have to admit that when I first saw this and I saw this integral here, I said, oh, it must be a calculator question. But I'm like, no, I gave them a non-calculator question. And it is a non-calculator question. We can do this integral. I got a product of things there, and we learned a method that sometimes works for integrals like this, and of course is integration by parts. And then we have LIPET, right? L-I-P-E-T. No logarithmic function there, no inverse trig function there, but we have a polynomial function there. That's x minus 3, so I'm going to use that to be u. So I'm going to say u is equal to x minus 3, and of course the rest of this is dv, and that would be this part, e to the x dx. So if u is equal to x minus 3, du is equal to 1 dx, or du equals dx, and of course over here v is equal to e to the x. Okay, so f of 3 is going to be what? Well, it's going to be 7 plus, so we do uv, so that's going to be x minus 3 times e to the x, minus the integral of v du, so what's that? That's going to be e to the x times dx, right? So e to the x dx. And now, a lot of the times when we did integration by parts, I think most of the problems we did, we were working with indefinite integrals. We did a couple of them with definite integrals, though. And that's another reason I wanted to take a look at this question, because it's a nice way to take a look at the definite integral and how you would handle it in the scenario of an integration by parts like this. So this is going to be the integral from 1 to 3, but what we can't forget is we're going to apply that limit from 1 to 3 also to this part, the x minus 3 times e to the x. So I really wanted to point that part out here too, right? All right, so let's do it. So we have f of 3 is equal to 7 plus this stuff. So x minus 3 times e to the x minus, of course, the antiderivative of e to the x is e to the x. And what we're going to do is evaluate this entire expression from 1 to 3, not just this, but all of this. All right, so let's carefully do this and see where it takes us. So we have 7 plus. So I'm going to plug in 3 into all of this, and then I'm going to plug in 1 into all of this, and then perform the subtraction. So I'm going to have 0 times e to the third minus e to the third. So that's my plugging in of 3 here. I'm going to plug in 1 into all of this. I have to subtract all of it, though. So it's 1 minus 3, so it's negative 2 times e to the first minus e to the first. All right, so we have f of 3 is equal to 7 plus, well, that's 0, that's a negative e cubed, minus, and this is a negative 2e minus e. So f of 3 is going to turn into 7, and then plus a negative e cubed, so that's a negative e cubed, and then plus a negative, in other words, minus this, so that's minus a negative 3e, I guess. So f of 3 is going to be 7 minus e cubed plus 3e. And yes, a lot of you got that answer by not doing it this way at all, which is totally fine, it's legitimate, but I wanted to go through this process because I wanted to go over that form that the AP exam likes to use. And this is also a nice, good review of how to do integration by parts for a definite integral. So there's our answer. F of 3 is equal to 7 minus e cubed plus 3e.